Alrighty, what's up everybody? Dirk here. Welcome once again to the dungeon. I already got a request to do a how-to video on this. This is the 555 based polyphonic keyboard. So we'll start out with the schematic. This isn't a full schematic. It's basically, you're going to basically type in to Google either 555 piano or organ, and you're going to come up with something like this. So there's your 555. Here's your keys with the resistors underneath, and your speaker. General 555 circuit. I believe this is in a stable mode. Yes, this is in a stable mode. There's two typical modes. For the 555, you have monostable, which is basically a trigger for clocks, and then you have astable, basically. And I unfortunately forget what astable actually does. That's something you have to look up, but it's not necessarily important for this application. You just keep in mind this is an astable setup that goes through these different keys, and each key that you press is obviously going to make a sound. A voice, basically. Each key is a voice. And I believe with this, the way this is right here, you can possibly play two voices, which means you can press two keys at the same time, and that'll count up the resistance you have here, and it'll change the frequency, which gives you a different tone. So you're going to take this circuit, and you're going to build it basically 32 times. Alright? This is also the last two right here. This is 30 and the last two. So this circuit 32 times for each key. So each 555 gets its own individual key. And the key, all these white oops, not that. All these white wires corresponds to a key, so that from the key, white wire, out to its resistor, which is in between. I believe it's in between 6 and 7. How did I do that? No, it's gonna be one of these right here. So you're gonna take this away, disregard the speaker as well. So you're gonna have something kind of like this. You're gonna have that's a 10. Looks like it's a 10K. Is that a 10K? Yes. So a 10K resistor and your 100 nanofarad capacitor, which is right here. Here's your 100 nanofarad, and on the other side you have your 10K resistor. And then you have to figure out what you need for each secondary resistor, basically, because this the resistor comes out. You have your 10K here between 6 and 7, and then you have another one that comes from 7 over to the positive rail, which you can see here. All underneath here is negative. So you have to figure out what that resistor is for each key. Now, I have to look here. Aha. Okay. So, this is something that you can print out. Basically, all the keys. This is a 32 key keyboard. And this is the 32 keys. And obviously each key is going to need its own specific frequency. Mine, this key right here, is around 34, or 43, I'm sorry, a bit backwards speaking German, 43.6 hertz. And that needed about 320 kilo ohm resistor. And the highest, right here, is 261.6 hertz. You can round these off if you want to, and that was a 52K. But I actually had to change some of these because they didn't work out so well. So what I suggest is, if you do build this, is to build all this first. Build the whole circuitry, lay out your keyboard, get all the wires where it needs to go, and instead of using these fixed resistors like I did, Some of these are trim pots. I would suggest getting, for each resistor going from the key, or from pin 7 through the resistor into the key, and then onto the positive rail, which is this yellow wire. Inside here is a positive rail, right? And that goes over to the positive. This is right here. You want a trim pot like this, or whatever kind of trim pot that you can get. I would suggest between I'd get a whole load of 500K, right? At least for this application. If you use different a different resistor and a different capacitor, you're going to get a different frequency, basically. So if you do what I did with a 10K and 100 nanofarad, get yourself 32 or even a couple extra trim pots at 500K a piece, all 500K, and that way it's a lot easier to tune the keys, right? Some of these I had to do because these resistor values are really crazy sometimes, and it's not so easy to take a bunch of resistors and put them together. Because not all these keys are tuned correctly. These are pretty good, actually. Favor this side a little bit more. I'll have to work on this side some, but I'm waiting to get my my trim pots, basically. That is a must for this circuit. Trim pots. You need it. What else do I want to go through? Well, how do you go about figuring out the frequency that you need? Well, you can go on Google and you can type in electronic keyboard keys, and there was a wiki page that gives a frequency for all 88 keys. And this is only 32, but it goes from 1 to 88, and it'll give you the frequency for all of your keys. And that's how I did it. So I just printed this out, 32 keys, and I started at the very bottom, and I just went through up to 32 and did all the frequencies. And then, well, you're gonna need either you're a musician, and you can just tell by ear if a certain key, a certain note is in tune or not. And that's basically what you can do, is you can tweak your trim pot, hold, and keep pressing the key until you think it's right. That's the right frequency. If you're not a musician, you can either use an oscilloscope, analog or digital, or you can use a frequency counter. Well, I have mine over there. I'm not going to pull it out, but a frequency counter is what I used. It's pretty simple, and that's how we'll figure out if I'm getting to the right frequency. Is to use that, basically. And what you can also do with the oh man, my fucking brain's not working right now. The frequency counter, basically, is you can get yourself an online function generator, basically, because this is square wave. So you go to the online function generator. You'll set it to the whatever frequency you need at square wave, and you can compare them. When you get the trim pot up there, and the frequency counter says, yeah, it's so so many hertz, because this is all in hertz. It doesn't go up to the kilohertz, and you can compare what the frequency is, the tone from the key. You can compare that with the function generator that's online. If they sound the same, then hey, you're in tune. If not, well, you got to play with it some more. That's what I can suggest doing. You could probably just even use the online function generator without the frequency counter and tweak the potentiometer until they sound the same. That's what you can do. What else? Right here. These are all the outputs, all these red wires. They go through a 10 microfarad capacitor and a 1.2 k ohm resistor onto its own, positive signal you know, rail right here, and that feeds out right here basically. And then there's your output jack right there that goes into an amplifier, and you will need an amplifier of some sort. This is a home built one that I did, but you can look online. You can do an LM386, or you can just do some standard transistor ones. I don't know, a class A or class B. You just have to look and experiment with that. But this is kind of like you know, because each signal is going to need at least 10 microfarads, and this is to you know, to drop a bit of the output signal, so you know they can't. Well, I don't know if they would run into one another, you know, because you're going to have conflicting signals. This could probably be better done with some of the kind of mixer. I'm going to be experimenting with that later with an op amp, so where each of these signals comes into an op amp and it works as a mixer basically. Yeah. Not much I can really, you know, else say about this. It's really simple. You're just going to build 32 of these, and instead of using these, you know, you're just gonna, you know, each key right there, and then your resistor would go there. Your trim pot, not those resistors, a trim pot going through the key, positive rail, 32 times. That's really it. It's simple. You know, and this is a must. Between 1 and 10K for the resistors. I just happen to have enough of these 1.2Ks, and you're going to need 32 of these at least 10 microfarad capacitors for the output. You know, that's what it says, right? You know, for example, that's a 22. You know, remember that it's the negative is going to be coming out, so that's your positive, and that's your negative coming out to the speaker, which goes, and the speaker goes to ground, obviously. You know, that's about it. Maybe make life easier. You can use some of these header pins like I use right here, and this is a positive rail, and that's a negative rail, and you can stick it a bunch of other things if you want to. Like I built this this LFO right here with another 555. Give you guys a demo. Sounds pretty cool, I think. You know, and that's on board. That's permanent. So. I can't really play it right now. Yeah, you get the idea. Now you can turn it up a little bit more. Yeah. So that's basically about it. It's you know, pretty simple, pretty straightforward. I mean, if you have any more questions or something like that, you know, please let me know in the comments below. I don't want to keep this video too long, because it's already 13 damn minutes. So, yeah. And until then, cheers!